السلام عليكم ورحمة الله وبركاته. أسعد الله أوقاتكم بكل خير في كل زمان ومكان تشاهدون هذا الفيديو. Welcome all of you and hope inshallah you're having a good start in this course and in the other courses for this semester. Today inshallah we are going to have the second lecture for the course of Instrumentation and Measurement 1 at JUBAIL Industrial College. It's going to be inshallah an extended for what we have done in the previous lecture. So in the start, uh, let's have a quick review for whatever we have done in the last lecture. So in the previous lecture, we started with a review of basic math, and in this file, I mentioned some point that is very important for any student to go through to just take a review for some basic math that we are going to use in this course or in your courses in the engineering field. The second point were the importance of units of measurement, and we mentioned that the units are very important in the measurement, and uh, any values will be meaningless without a unit. And we go through systems of unit, and we mentioned that we have two main systems of units in this course we are going to use, which is the international system of unit that has meter, kilogram for measurements, and the other system is the English engineering system of unit, which are using the feet, bound mass, and bound force for measurements. And last thing, for the previous lecture, we went through unit conversion. We know how to convert the units between different systems or for the units within same system, and we know how to safely convert between the units, how to follow the procedure to avoid any mistakes in unit conversion. Uh, this week we are going to have these three outlines or these three sections. It's going to be somehow long, but it's a very important to focus during this lecture and having solved the examples and exercises for this lecture. So in the beginning, we are going to study the representation of the derived units in their base units form, and we have a file that is called an SI tree of units. In this file, we are showing different derived units and how they combine or how they are connected to the base units. The second section will be some instrument terminologies or parameters that are uh, very important to know for different devices and measurements and for some devices selection. The third point will be the properties of materials or matters. So let's start with the first section, which is the representation of derived units in their base units form. So the main thing in this section will be this SI tree of units. So this file is already attached in the blackboard, and as you can see, this tree of units has uh, many units. However, we already said in the previous lecture that international system of units has two types of units. So they are classifying the system as the two parts of units. The first one is the derived units, and the second one is the base units. So what is derived units? We defined the derived units last week as, since as name implies, okay, so since its name is derived, so it's already derived from different combination of base units. For example, if we say a newton it's just a derived unit. But if we go back or trying to find the origin of the newton, we will see that it consists of kilogram, meter, and second. Okay, so this is uh, a classification for the units, which is called the derived, and it's named as a newton. However, it is a combination for different base units like kilogram, meter, and second. So the base units in the international system, the whole derived units are derived, okay, from a combination of only 7 units. And these are called the base units. The first one is called the meter, okay, which is the unit of length. The second one is called the kilogram, which is the unit of mass. The third one is the second, which is a unit of time. Kelvin, it's a unit of temperature. Ampere, it's a unit of electrical current. And mole, which is a unit of amount of substance. And candela, which is a unit of light intensity. Okay, so these are different physical quantities and their units, and we can see that in the first part, okay, which is this part, it is showing the base units. It's showing 5 base units, and we will focus on these 5 base units, okay? We will not go through the mole and candela in this course or in our examples. And in the second part, we can see different derived units or examples of derived units, such as area, volume, acceleration, and so on. Now, how can we represent these units, okay, using the base unit? So, all of the derived units, which is shown in the second part, okay, are combination of some or all of the base units. Now we need to know how to represent the derived units in their base units form. Okay, we will follow some procedures and we need to follow it safely in order to avoid any possibilities of mistakes during the representation or conversion. So, first, let's take an example. It's a better to have a motivation example to understand the concept. So first, let's express Pascal in its base units form. And we are going to use whatever you want. I already attached 2 files for the SI3 units. They are exactly the same. This is the first one, okay? And we can see that the base units are shown here as meter, kilogram, second, ampere, Kelvin, mole, candela, okay? These two are called supplementary units, okay? So we will not go through them. So we have 7 units, and we will focus on only these 5, which is meter, kilogram, second, ampere, Kelvin, okay? And all of what you have seen here as a green circle, okay, is called derived units, okay? So this is I3 units. It shows the connection between the derived units and the base units. Now, the second file is called this I3 units. I already attached. They are completely the same, okay? You can choose whatever you want to study. I prefer this one. It is clear and you can solve the examples clearly. So, taking the example as a Pascal in its base unit form. So, in this tree of units, we are going to have this Pascal, okay, to solve. Okay, this Pascal to solve. So we are going to have or express or convert or show Pascal in its base unit form. Now Pascal, it's a unit of pressure, okay, and it is a derived unit. So what is the base unit form of Pascal? So first we need to use the attached SI3 units, which is already shown before, and follow the procedure to safely, okay? So I'm repeating again and again the word safely. I already mentioned the last lecture that I said how to safely convert from unit to another. You can use whatever method or technique, okay, to show the answer. and it's going to be considered as a correct answer if it's right. Okay, so no one gonna force you to let me say to follow some procedure, but these are safe procedure to avoid any possibilities for mistakes. So I cut the picture for Pascal, and let's start the procedure one by one. So first, it says look at the unit Pascal in the tree. Look at the unit Pascal in the tree. So if you have the whole tree, what you are going to do is to look directly to Pascal. Now, next step, it is very important. Count how many arrows are coming. And see, I already highlighted the word coming. Sometimes you will see some units that they have different arrows. Some of them are coming or entering the unit, and some are leaving the unit or going out from the unit. These arrows that are leaving the unit, we will ignore it, okay? We will ignore it. So we will see or focus on the arrows that are coming to the unit, like this, sorry, like this. We will not consider any arrow coming out or leaving the units. The third step is multiply the number of arrows as a number of fractions. For example, if you have two arrows, you will multiply by two fraction. If you have three arrows, you multiply by three fractions. So it's easy. Up to now, it is so easy. Each fraction will take the units of the coming arrow. So all of these coming arrows, okay, representing some other units that affecting on the main unit. So each fraction will take the unit of such arrow. For example, if you have two arrows, the first fraction will take the unit of the arrow number 1, and the second fraction will take the unit of arrow number 2. The fourth step, it says, if the arrow is solid, okay, if the arrow is solid, and what we mean by solid, it is like this, okay? So it says, if the arrow is solid, it means that you multiply. And when we say in the fraction, that it's multiplication, so we will put it in the numerator of the fraction, okay? We will put it in the numerator of fraction. So any unit that has a solid line, we will put it in the numerator of its fraction. Now, what about the second case? It says if the arrow is dashed, and what we mean by dashed, it's like this. Okay, so if the arrow is dashed, it means divide. So that units that are coming from a dashed line, we will put it in the denominator of its fraction. Okay, we will put it in the denominator since the denominator represents the division. So far, it is easy. Okay, so if you follow this procedure, it is going to be very easy. Sometimes it might be long, but at least you have enough confidence that you will reach the correct answer. Now, 6, it says check. After you put the fractions, okay, you are going to check whether you reach the base or not. So you will check all the units that you have. Is it one of the 7 units or not? If some unit, okay, if yes, so you can, your answer is done. You just simplify the units that are repeated or same at either same numerator or denominator, or they are in different numerator and denominator. So you will make division and multiplication, and you add the power or subtract the power, whatever it is. But if not, it means that if there is some unit, okay, if there is some unit that are not belong to the base, so again, you need to solve for that unit. You need to solve for that unit, okay? So The last step, it says you complete your solution until you reach that all the units are base. It means all the units are one of the five units that we are going to take and simplify by cancelling the same units in the top and bottom, or add or subtract the exponents of the units. For example, if you have meter to the power 5 divided by meter to the power 2, you will subtract the exponent 5 minus 2, and you will get the final answer as meter cube. On the other hand, if you multiply meter cube by meter square, you will add the exponent, and you will have 3 plus 2 is equal 5. So it's going to be meter to the power 5. So now let's start solving for Pascal. Okay, so let us go here. So let's take an examples. Okay, we will take Pascal as chosen in the example. So first we will write here Pascal equal. Okay, and we will count how many arrows that are coming to the Pascal. Okay, how many arrows that are coming to Pascal. So this is the first one. Okay, and this is the second one. So we will have two fractions. We will write two fraction as a multiplication. Now let's go for the first fraction. We can see that the first fraction, okay, it is coming from Newton, okay. So since it's a solid line, we will put it in the numerator. So we will write Newton in the uh, Newton in the numerator of the first fraction, okay. Now the denominator will be 1, okay, it's easy. The second one, we can see that we have a meter square, okay, we will have a meter square, but see the arrow, it is a dashed. So meter square is going to be in the second fraction as a denominator since it's a divide, okay? So we will have a meter square, and here we will put 1, okay? Now what does it say? It says that check whether you have all as base units or not. We can see unit, Newton, well, it's not one of these seven, okay? It's not one of these seven base unit. So we still need to simplify again to solve again for Newton. However, let's see for meter square, okay? Meter square, see, I don't care about how multiple the units are in the answer, okay? I need to see only the units. So meter, it's one of the base unit. So here we reach the base in meter square. Because meter square is just meter multiply meter. So they are both base units, okay? They are both base units. Now, let's solve for Newton, but check. Now, since meter square, okay, since meter square is already base, so we can put it in the first, as a first fraction, and we will start solving for Newton after the meter square. So what are we going to do is writing Pascal, okay? Pascal is equal, let's bring 1 over meter square here first, okay? And then solve for Newton. Now go at Newton. So here you will check for Newton, okay? You will check for Newton, and for Newton you can see that how many arrows that are coming to Newton. So ignore any arrow that leaving the unit. So this one is leaving, okay? And this one is leaving. So ignore them. However, these two are coming. Okay, these two are coming to the unit. So let's check these two where they are coming from. So the first one, and we can see that both they are solid line. Sorry, both they are solid line. So what we are going to check now, since they are solid line, so both of them will be in the numerator of fraction. So first, we need to have two fractions. We need to have two fractions as multiplication. Now we are solving for Newton only. Okay, so what does this fraction comes from, or the arrows comes from? So the first one is coming from meter per square second, which is this one. Okay, so let's write meter per square second as it is, while the second arrow is coming as this one. Okay, so this is the second arrow, and let's see where it comes from. It comes from kilogram. It comes from kilogram as a solid line, so we will put it in the numerator, and the denominator will be 1. Now let's check. We already said that meter square is already base. Now, one point that this is the Newton base unit. This is the Newton derivation, okay? So, by checking, meter is base, second base, kilogram is base. So as we said that in this step that it says complete until you reach all the units are base, okay? And what does it say? Simplify by cancelling the same units in the top and bottom, or add, subtract the powers of the units. So what we have here, let me rewrite it again in a good manner. So Pascal is equal 1 over square meter multiply meter per square second multiply kilogram. So what can we say now? That we have a meter in the numerator and meter square in the denominator. So what we can do is by cancelling the 1 in the numerator by 1 of the denominator 1. So the final answer will be Pascal is equal, rearrange, kilogram per meter second square. On other answers, or in the book, you can see that this kilogram, and we will raise whatever in the denominator as a numerator by changing the sign of the exponent as meter to the power minus 1, second to the power minus 2. Okay, this is the answer for Pascal. Now, another example. Let's find another example. So let's go for um, let's see a column. Okay, let's see this one, which is the column. Okay, let's try to solve for column. Now, first, write column is equal, which is a unit of charge. Okay, and let's see how many arrows that are coming from the column to the column, sorry. So we have two arrows, so we will multiply two fractions. And let's see the first arrow. The first one comes from ampere as a solid, so we will put it in the numerator, ampere divided by 1. And the second arrow is coming from the second, and it's solid again, so we will put second and divided by 1. Now, it says check whether you reach the base unit or not. So we can say that ampere, it's already base, okay? And second, it's already base. So the expression or representation of the column unit in its base unit form equal ampere second. Ampere second. This is the column unit. Now, let's take another example. Let's find let's find joule. Let us go for joule, which is a unit of energy. So joule here, it is in the top. Okay. So let's write here joule is equal. How many arrows that are coming to the unit? We have two arrows, this one and this one. Okay. The other three are leaving, so we will ignore them. So we will write two fractions. This one, the first one, and this is the second. And let's see the first arrow. So the first arrow is this one. So we'll consider this one. It comes from the meter, okay, as a solid line. So we will put meter in the numerator and 1 in the denominator divided by 1. And the second arrow as a solid comes from Newton, okay. So sorry. So we will put a Newton since it's a solid line in the numerator and 1 in the denominator and check whether you reach the base unit or not. So we will see that meter it's already base while in Newton it's not base, okay, as the first one, as the first example. So let's solve again for Newton and we will write here joule is equal and we will write meter as it is multiply. Now I can open brackets that's shown that I'm solving for a Newton. And in the first one, we can see that Newton, it's a kilogram, which is this one, okay? This one is a Newton, okay? So it's a kilogram meter per square second. So let me write kilogram meter per square second, kilogram multiply meter per square second. Now let me rewrite again and find the simplification. But before that, let me check whether I reach the base unit or not. Meter already said that it's a base. Kilogram, it's a base. Meter, again, it's a base. Second, it's a base. I don't care about the exponent, okay? Since we have second, it is a base unit. So let me simplify so that we can say that we have meter here and meter here, both in the numerator. So we will add the exponent 1 plus 1. It's going to be meter square. So at the end, joules or 1 joule is represented as kilogram meter square divided by second square. Now, these are three examples. You can solve different examples, okay, and you can find in the book at page uh, A.2, okay, page 274 in the textbook, okay, you can find the table with all the derived units or most of the derived units with its expression of base units form. This is the table at page 274 in the textbook, and you can see these are all the derived units and these are all the expression in base units form. Okay, so you can have practice and show me the procedure if you want to check the answer. So this is regarding the first section, which is the representation of derived units in their base units form. And it's very important to me, for me, okay, to know how to express these units and solve different questions. Now let's go for the second section, which is the instrument terminologies or parameters, okay? And most of these parameters you are going to take in the lab experiments, especially the first experiments. You are going to have maybe half of these expression and learn half of these terminologies and learn them very well, okay? And apply some calculations and solve some questions in the lab sessions. However, here we are just reminding and extending the importance of learning them. So, for any measurement system, there are different key parameters, okay, that need to be known, okay, and understood to follow the specifications. So below we will list some of these parameters or terminologies which will be explained in the slide one by one. So the first one is range, the second one is span, resolution, calibration, error, accuracy, precision, and all of these, okay, will be studied at one experiment, which is the first experiment in the pressure measurements for the lab session. Okay, so after the first experiment in the lab, you are requested or required to understand all of these seven, okay, plus some of the others terminologies, which are linearity, hysteresis, sensitivity, threshold, drift, maintainability, and reliability. There are many other terminologies, okay, but we list some of these important parameters. Now let's start explain each one separately. So the first one, range. What do we mean by range? Okay, once you hear a range, you will understand that it's a limit of the measurements. What do I mean by limits? It's showing the minimum and maximum value for the measurements or for any device that can measure. So you will mention two values with their units. If you have been asked what is the range, so you will mention two values. If you mention a single value, it's not a complete answer. Two values. What are these values? The minimum and maximum value of that measurement. So this is range. Now what about the second one, which is the span? Span, it is the difference between maximum value and minimum value. So in the range, we said that you mentioned the two value, which are the minimum and maximum. What about the span? The span is the difference between them. So for example, if you have a device that measures from 0 or let's say from 10 to 110, okay, so the range is from 10 to 110, for example, degrees Celsius if it's a temperature gauge. Okay, now what about the span? The span is the difference between these two values, between the maximum and minimum. So we will take 110 minus 10, and the answer is 100 degrees Celsius. Okay, so only one value. Now, what about the third one? Okay, which most of the students they got confused in this one. Okay, it's a very easy. It's a very easy. Resolution, it is the smallest change of input. Okay, any change of input that comes to that device, for example, that can be measured reliably or that can be measured clearly without any assumption. In other words, it's the value for each division in the device. Now, how to calculate the resolution? Okay, so using this formula, it says it is the difference between two consecutive values, okay, يعني متتالية, divided by the number of spaces between them. Let's take an example of this device. Okay, so showing this temperature gauge, it says find the range, span, and resolution of the following gauge. Now, how do I know that it's a temperature? Most of the gauges that they have scales, okay, and pointer. Now, in order to know what quantity it's measured, you can see the unit, okay, so it shows here degree Fahrenheit. It means it's a temperature gauge. So easily it says find the range, span, resolution. Now, the range and span will be very easy. Let me explain the resolution. Okay, let me explain the resolution. Now, what does it mean? Difference between two consecutive values. Difference between two consecutive values. What are these consecutive values or قيم متتالية؟ وش أقصد فيها؟ 160 and 180 are two consecutive values. However, 160 and 200 they are not two consecutive values مش متتاليين بينهم 180 okay so you are taking the difference between two consecutive values okay this is the difference so the difference between 180 and 160 is 2 oh sorry 20 okay divided by number of spaces between them it's easy so how many space this is called space, okay, or division. So how many space between 160 and 180? This is the space 1 and this is space 2, okay? So we have two spaces between 160 and 180. So it's now, I think it's a very easy, but most of the students, they are confusing. You just need to focus and answer with a complete concentration, okay? Do not be in hurry. So the range, we can say that it's from the minimum to maximum with the units, okay? So we can say that it's from 140 to 280 degrees Fahrenheit. So you need to mention the two values in the range. What about the span? The span, we said that you are taking the difference between these values. So we have here 140 and 280, okay? So the difference between them is the span, which is 140 degrees Fahrenheit, okay? The unit is very important, okay? If you miss the unit, it means you miss the whole answer. This is according to my style, okay? Now, what about the resolution? The resolution, as we said, that you are taking two consecutive values. In this example, we take 160 and 140, okay? So we take the difference between them, which is 20 divided by how many spaces between 140 and 160. So this is space, and this is another space. Okay, so we divide by 2. The answer is 10 degree Fahrenheit. What does it mean? What does it mean 10 degree Fahrenheit? Again, it says in the definition, it is the value for each division in the device. So the value of this one is 10. 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 So it's a value for each space or division in the device. So if someone asks you what is the value of this one, okay, if the pointer comes here, there is no number here. But since you know the resolution, you will say that since the resolution between 180 to 200 is 10 degree Fahrenheit, so each space has a value of 10. So from 180 to this line, we will add 10. So the reading is 190. Okay, the reading is 190 degree Fahrenheit. I think it's easy. Let's take some examples. But before that, there's an important note, okay, that most of you have to know it, okay? It says that some gauges have more than one resolution, okay? So what if the gauge has more than resolution? If so, it means that if there is a gauge that has more than one resolution, you need to mention and solve for all the resolutions with their range in the gauge. What does it mean? It means that if the resolution from 180 to 200 is, let's say, 5, and the resolution from 220 to 260 is 10, what you are going to say, you will say that the resolution from 180 to 200 is 5 degree Fahrenheit, and the resolution, this is number 2, the resolution from 220 to 260 is 10 degree Fahrenheit. Okay, so you need to mention all the resolutions in the device. Now let's take some examples. Uh, this is one of the gauges, okay, and we say that how to know what quantity that this gauge measures. You will see the unit. So in this gauge, the unit is bar, and the bar is a unit of pressure. So you will say this is a pressure gauge. Okay, you will say this is a pressure gauge. Okay, What is the range? It's easy, okay? So you'll see the minimum value, okay, and maximum value with the units, okay? With the unit, do not forget the unit. And you will say that the range is from 0 to 10 bar. This is the range. Now, what about the span? The span is the difference between these two values. So you will say that maximum, which is 10, minus 0, which is the minimum, the span is 10 bar. You can see that in the span, only one value. It's a mathematical expression. And in the range, you will see that you have two, or you mention two values in the answer. Okay. Now let's see uh, the resolution. The resolution says that you take the difference between two consecutive values, for example, from 0 to 2. Okay. So the difference between them is 2 minus 0, okay, divided by how many spaces or divisions between them. Let's count. So here, this is the first one, second, third, 4, 5, 6, 7, 8, 9, 10. So between 0 and 2, we have 10 divisions. So we will divide by 10. So the answer is 2 over 10, which is equal zero point 0.2, and you need to mention the unit again, okay? 0.2 bar. Okay, the answer is 0.2 bar. 2 divided by 10 is 0.2. Now, how to check that your answer is correct or not? You just evaluate the zero point 0.2 for each division and go from 0 to the second value, which is 2. If you reach 2, okay, by adding zero point 0.2 for each division, it means that your answer is correct. So let's try. So here, zero point 0.2, zero point 0.4, zero point 0.6, zero point 0.8, this is 1, 1.2, 1.4, 1.6, 1.8, 2. So your answer is correct. Now, you need to check for the whole gauge, because we mentioned that some gauges they have more than one resolution. So you need to make sure that this resolution is spread across all the gauge, and the gauge has only one resolution. Otherwise, you need to solve for the other resolution and mention this resolution is affected, okay, from this value to the other value. So let's check here: 2, 2.2, 0.4, 0.6, 0.8, 1, 3.2, 3.4, 3.6, 3.8, 4. So I think all of the gauge has only one resolution. So you need to check for the whole gauge, and at the end you will get only one resolution. So that's the answer. Another example. Now it says find the range, span, resolution, and what is the reading right now on the gauge. So let's start with the range. The range is showing the minimum and maximum, and do not forget the units, which is this one is the temperature gauge. So what you write that from 0 to 120 degrees Celsius. Okay. What about the span? The span is the difference between the maximum and minimum, which is equal 120 degree Celsius. Resolution. Take two consecutive values, for example, 0 and 20. Okay, let me check for 20 to 40. Okay, from 20 to 40. Okay, and you will take the difference between these two values. What you will write, you will say that 40 minus 20 divided by what? You will divide by the number of spaces or divisions between 20 and 40. So let's count. This is the first space. 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have 10 divisions between 20 and 40. So do the math. 20 over 10, you will get 2 degrees Celsius. What does it mean? 2. It means that the value for each space, okay, is equal to. So this one, 2, 2, 2, 2. So at each time you will add by 2 to find the value. So we said how to check. In order to check, you will add 2 until from the value 20 until you reach 40. If you reach 40 by adding the 2, so it means your answer is correct. So let us check here 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. So your answer is correct. And again, you need to check for the whole gauge. Okay, you need to check for the whole gauge if it has the same resolution. So its resolution is 2 degrees Celsius. If not, so you need to mention all the resolutions in the gauge and where they are affected. So the reading. Okay, so since the resolution is 2, the reading here is 22, 24, 26, here 28. So let's write here 28, and this one is 30. Okay, the pointer, it comes between 28 and 30, so you can say the reading is 29 degree Celsius. Okay, so this is the assumption. Okay, this is the assumption. But since you know the resolution, your answer will be mostly accurate to high percentage. Okay, uh, this is the third example, and here we have two scales. Okay, we have two scales. One is one has the red color and the other is the outer scale which has the black color. So solve for the two scales. Okay, find the information or answer the question for the two scales. Let's start with the red one, the inner scale. The inner scale, and we can see here that the units are kilopascal and psi. So this one is a pressure gauge. Now the range in the red scale, okay, here we have 0 to 700 kilopascal. So you will write 0 to 700 kilopascal. Okay. What about the span? The span is 700 minus 0 equal 700 kilopascal. Do not forget the unit. Do not forget the unit. What about the resolution? The resolution, let's find two consecutive values, let's say 100 and 200, and count the spaces between them. So first let me write the difference between 200 and 100, okay, and divide by number of spaces between them. Let's count. So here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So divided by 10, the answer is 100 divided by 10. So the answer is 10 kilopascal. Let's check. Okay, let's check. So here 100, 110, 20, 30, 40, 150, 60, 70, 80, 190, and 200. So your answer is correct. Okay. Now let's go for the, and again you need to check the whole scale whether it has same resolution or different resolutions. Now for the second scale, which is the outer one, the range is from 0 to 100 psi. So here you write from 0 to 100 psi. Okay. The span is the difference between the maximum and minimum. So 100 minus 0, the answer is 100 psi. Again, the unit is important. The resolution, take any two consecutive values. Let's find the for example 20 and 30, okay, and let's count the spaces between them. But before that, let me write 30 minus 20, which is the difference between these two values, divided by the number of spaces between them. Let's count here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Again, we have here 10 divisions or 10 spaces. So the answer is 10 divided by 10. Now it's equal 1 psi. Okay, now it's equal 1 psi. Again, let's check our answer. So here 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So the answer is correct. The answer is correct. And the resolution is 1 psi for each space. Now this is uh, okay. I put the two examples as the same to solve for the two scales, but I answered them in one slide. Try to solve these examples and exercise for the different gauges, and then show me the answer. Now let's go for the next terminology. Here we have finished now the range, span, and resolution, which is the first three terminologies mentioned in the introduction. Now the fourth point is the calibration. Okay, the calibration. Now what does it mean, calibration? Now if you want to measure something, okay, if you have a device of measurements, uh, you are going to have this device and install it in, for example, industry. Okay, so the first thing you need to get from this device is the accurate measurements. You need to make sure that its measurement or the values that you will get or you measure from this device is accurate. تحتاج إنه القيمة تكون دقيقة. So how to know these values are accurate or not? So you need to compare the values of this device with some other reference device that has a known values. Okay, that you know that most of the values from this reference device are accurate. So the calibration, it is the process of comparison between reference or known values, okay, with some unknown values. This process is called calibration. So each time, okay, you have some measurement device, you need to do the calibration to check the accuracy of that device. Now, the fifth term is called the error. Error, it is defined as the difference between true value and measured value. So, what is this true values comes from? It comes from the reference device, okay, that you already compare with your measurement device. So, whatever values comes from that reference device, which is this one, okay, it is called true values. قيمة حقيقية، قيمة صحيحة. Okay? Now, what about the unknown values? Okay, which is the values comes from your measurements. It's not necessarily that it's going to be wrong, okay? But it's unknown to you, okay? You don't know whether it's measuring accurate or not. So you compare with some reference value. So these values, which comes from your measurement device, is called measured value. It's called the measured value. So the difference between these two values is called the error, اللي هو قيمة الخطأ. So if you compare, and for example, the true values is 10 degrees Celsius, okay, so you bring this to 10 degrees Celsius and apply it to your measurement device, which is, for example, the temperature gauge, and you get the measurements reading as a 10 degrees Celsius. So the error is the difference between the true value and measured value. Reference is 10 degrees Celsius and the measurement is again 10 degrees Celsius. The difference between them is zero, so the error is zero. You don't have any error. However, if it measures the 10 degrees Celsius as 9 degrees Celsius, the difference is 1 degree Celsius, so you have an error of 1 degree Celsius. Okay? Again, this terms are taken in the first experiment in the lab. Okay, so what is the formula for error? Error, it says the difference between true value and measured value, and mostly we are taking the positive quantity, okay? We are taking the quantity of error as a positive. So all the time we will have the absolute value, okay? We will have the absolute value. Now there is another term which is called the percentage error. The percentage error is by taking the error that you have, okay? You are taking the error and you divide it by the true value, which is the known value comes from the standard or reference device, and you will multiply by 100, you will get the percentage error. The next term is the accuracy. Okay, the accuracy, it is how the measured value. Now we need to check, we need to focus, okay? Focus on the next two terms. This one is the accuracy. The accuracy, it says اللي هي الدقة, how the measured value is close to the true value. Okay, so you're comparing the measured value with the correct value or the true value. So if the measured value are far away from the true value, you will say this device is not accurate. But if the measured value is very close or same as the true value, you will say this measurement is accurate. Okay? Now, uh, what is the formula for accuracy? Accuracy, the percentage accuracy, it is 100 minus percentage error. For example, if your measurement has a 30% error, okay, it means it's a 70% accurate. So it's 100 minus 30 equals 70, okay? So it's 100 minus the percentage error that you already calculated in this formula. Now, the next term is called the precision. Now look at the definition, okay? Most of the students, most of people, let's say, okay, they have confused or misunderstand between these two terms, okay? They mix between these two terms. Now let's see the definition of the precision. The precision, it says, it is how the repeated measured values, look, we have measured values, okay, are close. Is it to the true value? No, are close to each other. Okay, so as the repeated measured value for same input, I mean, okay, for example, if you check the 10 degrees Celsius 5 times, if you get the measured values, okay, all of these five are close to each other. For example, each time you get 10, 10, 10, 10 for the whole repeated measurements, okay, I can say that this device has high precision. However, if the values are far from each other, okay, this device, I can say that it has low precisions. Now, what's the difference between accuracy and precision? In the accuracy, we are comparing the measured value with the true value, okay, with the true value. But in precision, we are comparing the measured values with each other, okay, how they are close with each other. It doesn't have to be close to the true value. For example, some devices has high precision, okay, but they are far away from the true value. They are not accurate at all, but they have high precisions because all the time you measures for same value, okay, they are close to each other, but maybe it's far away from the true value. For example, for the 10 degrees Celsius that you measure, if you measure for the first time, for let's say you get 10, 20 degrees Celsius, you have an error of 10, okay? So it's far away from the true value. You measure it again, you get 20. You measure it again, you get it 20. So all the time you get 20 degrees Celsius. This device has a high precision in this measurement, but it's not accurate at all. It's far away from the true value, which is 10 degrees Celsius. So this is the main difference between the precision and accuracy. So what's the formula for precision? Precision, it says 1, okay, you subtract 1 minus absolute value, and you have fraction in the numerator. It's xmth minus xm divided by xm. Now, what is xnth and what is xm? Xnth, it is the individual specific measurements, okay? Individual or specific measurements. And xm, it is the average value of the measurements. For example, we said that you measure the 10 degree Celsius, okay, 5 times. And for example, you get these 5 times 20, 20, 20, 20, 20. So you will take the precision for, let me write it here. Okay, for example, this is the true value, and these are measured values for the value of 10 degrees Celsius. So in the first measurement, you get 20. The second one, you get 21. The third one, you get 19. The fourth one, you get 20. The fifth one, you get 20. So you repeat the measurements for the same value, same input, okay, 5 times, and you get these results. So what is xnth? Xnth, it is, for example, one of the measurements. For example, the second one. This is a specific measurements from the 5. Now, what is the xm? Xm, it is the average of all of these measurements. And we know how to find the mean value or to calculate the average. It is you add them divided by number of them. For example, the average of these value is by adding them 20 plus 21 plus 19 plus 20 plus 20. Now, what is the number of how many number of measurements we have? We have 1, 2, 3, 4, 5. So divided by 5. Okay, this is the mean value or average, or how to calculate the average. So accuracy versus precision. Okay, so what's the difference between accuracy and precision? Let's have an example of dartboard. Okay, in the dartboard, so here the first example, if you have five, if you throw 5 darts, okay, you have a test of 5. So as we can see here in the picture, that all the five, all the uh, five tests, okay, are in the true value, okay, and all of them are close to each other. So for the accuracy, we say it is how the measurements are close to the true value. So it is close to the true value or not. In precision, we said how the measured values are close to each other, whether it's far from true value or on the true value. Okay? So in the case of accuracy, we will say if it's close to the true value, we'll say it's high accuracy. If it's far, we'll say it's low accuracy. In the precision, if the measurements are close to each other, okay, or this specific measurements are close to the other measurements, we will say that it has a high precision. If it is far from the other measurements, we will say it's a low precision. So in this example, we will see that all the 5 measurements are close to the true value, okay, so high accuracy, and all of the measurements are close to each other, so high precision. Okay, so in this example, we can say it's a high accuracy and high precision. Let's take another one. Okay, see, here we have 5 tests. Okay, and all of these tests, as you can see, they are far away from the true value. Okay, so they are not accurate. But in terms of precision, you can see that most of the measurements, okay, or all of the measurements are close to each other. So we can say that this example is having a low accuracy but high precision, okay, but high precision. Now let's take third example here. We can see, okay, that most of the measurements are close to the true value. Okay, most of them they are close. So we can see and say at the same time that they are almost accurate. Okay, we can say it's a high accurate, okay, high accuracy, but each one are far from each other. Okay, each measurements are far from the other measurements, so we can say that they have a low precision. So high accuracy and low precision. What about the last one? We can see that here they are far from the true value and they are far from each other, so they have low accuracy and low precision. This is the main difference, and I think it's a good comparison and explanation between the accuracy and precisions. Now, here's an example for the terms of error, percentage error, accuracy, and precision. So let me write the formula. Error, it is true value minus measured value as absolute value. Percentage error, it is error divided by true value times 100. Okay, now percentage accuracy, it is 100 minus percentage error. This is you need to know, huh? And precision is equal 1 minus absolute value fraction, and you will take the division, the subtraction or the difference between specific measurements from the mean value or the average of the whole measurements for same true value. So in the questions, it is given the true value. So here the true value is 35 psi, and all the measured values are given, and we have here error, percentage accuracy, and precisions. Okay, and precisions. Now, let me first calculate the mean value. So the mean value, we said that you are taking the total or the sum of the measured values divided by number of them. Okay, so here we have xm is equal 30 plus 35 plus 38, and you will divide by 3, which is the number of measurements. The answer is 34.33. 34.33 BSI. This is the mean value or the average of the measured values. Now let's solve the first row, okay? And I will let the others for you to solve and practice. So the first one, the error, it says 5. So he take the true value and subtract it from the 30, which is the first measured value. The answer is 35 minus 30, it is 5. Now the percentage error, it says you take the error, which is 5, and you divide by the true value, which is here 35, and multiply by 100. Okay, so the answer is 5 divided by 35 multiply 100. Okay, you will get 14.28. 14, let me write it down. 14.28 percent. Okay, since it's a percentage. Now the accuracy, it is 100 minus the percentage of error. So 100 minus 14.28. So the answer is equal 85.71%. Okay. The precision, it says that 1 minus, you will take the absolute value of the specific measurement, which is xnth, which is here 30, minus the xm, which is the average here 34, 34.3, and you will divide by the mean value, which is 34.3. Now, as you can see here, the answer, it is negative, okay? But if you take in the absolute value, it will be positive. So all the time, you are taking the absolute value of this fraction, and we will get 1 minus 34.3 in order to get a positive value. Okay, divided by 34.3, and the answer is 0.87. Okay, 0.87 without any units. It's a unitless. So this measurement, okay, has a precision of 0.87 compared to the other measurements, measurements in terms of precision. Now try to solve for the other or for the rest of the blanks, and you can show me at any time to check the answer. Now here, this is a homework for you, and there is a bonus, okay, for those who are having or submitting complete answer, okay? Most of you, okay, most of you, they are going maybe to solve 50% of the answer. And I know most of you, they will answer 50%. Those students will not get the bonus. But the student that submit and solve the complete answer, okay, he will get a bonus. Okay, he will get a bonus. The exercise said that a pressure of 6.5 psi, now this one is the true value, was applied to under test pressure gauge. It means that this pressure gauge is under test to check the accuracy. So this is your measurement device. So this 6.5, okay, is called the true value. It's applied to the pressure gauge, another device to check the accuracy. After calculation, okay, by doing this table, for example, okay, the accuracy of the measurement, the accuracy of the measurement was taken as 96%. So 6.5 here, it is same as 35. And the accuracy of the measurements is 96%. It is like 85.71%. What was the measured value? He asked about this value as an example. So you have the true value, okay, and you have this accuracy, and he asked what is the measured value. Most of you, they will solve half of the answer, okay, but who can find the complete answer? Let's see. Okay, let's continue. The terminology or the term number 8 is called the linearity. We already explained the linearity, and it's the relationship between input and output for any systems. So if the input and output has a linear relationship, it means that the slope across or الميل, okay, the slope across any point in the line will be the same, and we know that all linear graphs are straight line, but not necessarily all straight lines are linear graphs. Okay, why? Because this one is straight line. If you have a graph and this is your line, this is a straight line. This one is a straight line, but they are not linear. Okay, they are not linear. So all linear must be straight line. This is for sure. But not all straight lines are necessarily linear. What about hysteresis? Hysteresis in the measurements, okay, sometimes you are going to see that you will take the measurements from 0 to maximum, okay, and then you go back from maximum to minimum. The reason for taking these measurements is to check the hysteresis of the device. So what is the definition of the hysteresis? It is the difference of measurements, okay, the difference of measurements for same input when you measure from opposite direction. What does it mean? It means that, for example, if you have or let me show the graph directly. Okay, here you can see that this is a typical linear graph. Okay, a typical linear line, straight line. Now, what about hysteresis? Hysteresis, for example, it says that for same input, for example, let's say at 20, these are the measurements, okay? These are the measurements when you are going from the minimum to maximum, okay? And this represent the measurements when you are coming from the maximum to minimum. If they are typical, if there is no difference, okay, when going from minimum to maximum, maximum to minimum, you will get like this line, okay? So going up or going down, you are having the values or the measurements at same values, okay? But if you have some hysteresis in the device, it means that for same input, let's say 20, okay, when you are going up, when you are going up, let me have this line, okay, you get the value here as y1, for example, okay? But when you are going down, you get the value here, okay, which is y2. Sorry, let me find another line, another color. It is y2, okay? This is called hysteresis. The difference between these two values are called hysteresis. So low hysteresis is better. High hysteresis is not preferred, okay? Is not good for the device in the measurements, okay? So if you have high hysteresis, it means the device has some weaknesses in the measurements. Now, the term number 10 is the sensitivity, which is the ratio of change in output to the change in input, and we can compare it with the slope, okay? So the sensitivity formula is you take the change in output divided by the change in input. So, so for example, if you have this table, okay, okay, this is input and this is output, and you have these values for the input, for example, 0, 10, 20, 30, and you get the output as 10, 30, or let me say 20, 30, 40, 50, okay? So the sensitivity is that you are taking uh, the sensitivity is equal delta output divided by delta input. So you are taking the change in this one and you divide it by the change of this one. So you take these two values, 30 and 0, okay, and you take the difference. This is delta input, okay, and take the difference between these two values, and this is the delta output. So the answer is going to be delta output is equal 50 minus 20 divided by delta input, which is 30 minus 0. So the answer is 30 over 30, which is equal 1. The unit of output divided by the unit of input. For example, if this is ampere and this is voltage, so the unit is ampere per voltage. Ampere per voltage. Okay, so this is regarding the sensitivity. Threshold, it is the maximum level needed for the output. Okay, for the output, this is the output. Okay, to respond to the input. ليستجيب للإنبوت، يعني يقول لك أعلى قيمة أوكي يحتاجها الاوتبوت اوكي من الانبوت عشان يستجيب. يعني for example this is the input huh. The input has this value, the output didn't respond, so still he didn't reach the value. Reach this one, the output doesn't respond, so it's still 0. If he reach this one, the input, okay, the output will start responding. Okay, the output will start responding. This value from 0 to that value is called the threshold. Okay, this value is called the threshold. So if the input of an phenomenon, okay, can be seen, sorry, if the input of an instrument is gradually increased from 0, it takes certain level before the output respond. This is the level and it's called the threshold. Okay, this phenomenon can be seen in semiconductor device, and you are going to see it in the course of electronics in the device called the diode, okay, which is a semiconductor device. In the diode, if you supply a voltage of zero point 0.1 volt, for example, of silicon diode, it will not respond. 0.2 volt, it will not respond. 0.3, 0.4 until you reach the value of 0.7 volt, the diode will start responding and it will open. Okay, so the threshold value for the silicon diode is 0.7 volt, which is the value that the output start respond. Now drift, it is the undesired change, okay, or unpreferred change, or the variation in the output over a period of time that is not or unrelated to the change in input. Sorry. So if there is one value of the input, okay, applied for some period of time, if you have some drift error, okay, the value will change after some time. With same input, the input doesn't change. This is happening in the devices for the reason of aging of instruments. So if the instrument has a long time, okay, without any maintenance or repairment, okay, so it might have some drift error. So if you supply or apply same input for a long time, sometimes if the device has a drift error, the reading will change slightly. So the last one is called, or before the last one is the maintainability. Okay, so it comes from the maintenance and ability. So it's how the device or how the instrument is able to be maintained or to have maintenance. So it's the probability that in the event of failure, okay, if some failure happen to the device, okay, some maintenance action would restore the system within a specified time. So maybe some repair or corrective action that can be performed on that instrument or device, and then we will restore it uh, and back it to the normal work or normal operation. The last one is the reliability. It comes from reliable. Okay, so it is the ability of that instrument to function satisfactory, okay, بشكل or acceptable, okay, within a specific working or different working condition for a state period of time. For example, if you have a reliable instrument in hot weather, it work perfect or satisfactory or acceptable. In humidity, it work again satisfactory. In dust weather, it works satisfactory. So with these different working condition, okay, or if you have high wind, there will be no vibration in the reading and change in the reading. So I can say it's a reliable instrument. Okay, so that's all about the instrument terminologies. So let's go for the properties of the materials, and this section is very important, and you need to solve the examples given at the end of this sections. So the first two properties will be taken as the mass and weight. Mass and weight, okay? These two terms, okay, are too often misused and misunderstood terms in mechanics and fluid mechanics. Many people they confuse or miss and mix between the mass and weight. So what's the difference between them? Well, mass is defined as a measure of amount of material in an object. So how much amount of the material in an object. So anywhere it will be the same. It doesn't change with body's position. Okay, if you move it from place to another place, the mass is same, still same, doesn't change. With movement, okay, or modification on its shape. Even if you change its shape, okay, the mass is still the same. Unless material or some material is added or removed. Unless you play with the amount of material that form that object. Okay, so all otherwise the mass is same. Now, for example, if you have an object with a mass of 1 kilogram on Earth, it will have the same mass of 1 kilogram if you put it in the moon. Okay, so the mass doesn't change regardless of the position and the movement that you have applied to it. So what about the weight? The weight, it's defined as the gravitational force, okay, and how this force pull the object to some specific location, okay? So it's a gravitational force acting on a body mass. So it's affected by the acceleration of gravity, and we can say that weight it's equal mass multiply the acceleration of gravity. Okay, weight it's a mass multiply an acceleration of gravity, and we can notice here that weight it's one type of force. So weight it is typically force, but it's not for any acceleration, it is due to the acceleration of gravity. So it's one type of the general definitions of the force, okay? So keep in mind this information. So for example, if an object with a mass of 1 kilogram, same as the above object, in the Earth would have different weight, not mass. Okay, this object will have the same mass on Earth and Moon, but it will have different weight when it is in the Earth or on the Moon. Okay, so how to calculate this one? That's because the acceleration of gravity on the Moon is approximately sixth of the acceleration of gravity on the Earth. Okay, so in g, sorry, g at Earth G at Earth is equal 9.81 meter per square second, but the acceleration of gravity on the moon is equal 9.81 divided by 6 meter per square second. So they will have different weight, but same mass, 1 kilogram will be kept the same. This is an example that here, if the mass of this man is 70 kilogram, okay, so here we have mass of 70 kilogram, and here we have the Earth and the Moon. We can notice and observe that the mass is kept the same. However, the acceleration of gravity here on the Earth, it's a 9.81 meter per square second, which is the same as Newton per kilogram. It's another representation and expression. And on the Moon, the acceleration of gravity is 1.63. Okay, so the weight, it's a multiplication of the mass and the acceleration of gravity. So the man has a weight on the earth as a 687 Newton, while on the moon he has a weight of 114 Newton. Okay, so this is the main differences between the mass and weight. So keep in mind that most of the people, okay, and the students, the mix between the mass and weights. Okay. Now, what are the units of mass and weight in SI and English engineering system? Well, in SI system, the mass has a unit of kilogram, while on the English system of units, it has a 1 pound mass. Now, the weight is a multiplication of acceleration of gravity. Okay. So in SI system, 1 kilogram mass would give a weight, okay, and 1 pound mass in English system would give a weight of here in the left side. In the SI, it would give a weight of 9.8 Newton, which is exactly equal, okay, kilogram meter per square second. However, in the English engineering system, the 1 pound mass would give a 1 pound force, okay? And this 1 pound force is equal 32.1 pound mass feet per square second. So in the SI system, the only units are represented in different way, okay? But the value is same. However, in the English engineering system, the value of 1 pound force is equal 32.1 pound mass feet per square second. So as you can see, in the English system, they changed the express the unit, okay, and the value, okay. They express and they change the unit and the value, while in the SI or international system of units, okay, they just change the expression of the units while they are having the same value. So in general, okay, in general, we will deal with the unit of pound force in our course, okay? So whatever pound mass you have, it will give the same value of pound force, okay? So in general, okay, in general, x pound mass, it will give a weight of same x pound force. This is an English engineering system. While in the international system, x kilogram of mass, okay, would give a weight of x times 9.8 Newton. Okay, x times 9.8 Newton. This is the main difference between the international system and the English engineering system. Now, the third other terms, which is the last section, okay, they are the density, specific weight, and specific gravity. Density, specific weight, and specific gravity. So the symbol for density is the rho symbol, okay? The symbol for specific weight is gamma, okay? And Sg represent the specific gravity. You have to know the differences between these three properties, okay? Most common mistakes comes from mixing and not understanding the difference between these three terms. Okay, so you have to solve the examples and exercise and practice all the questions in order to understand. So likewise, for the mass and weight, density and specific weight are so similar, and most of people they are mixing between these two properties. Now, what is density? Density is defined as mass per unit of volume. So rho, which represent the density, is equal mass divided by volume. Okay? Now, what about the specific weight? Specific weight is defined as, which is gamma, defined as weight per unit of volume. Now what you can see, Shabab, you can see that here in the density we are using mass, while in the specific weight we are using weight instead of mass. However, we are dividing by the same volume. Okay, we are dividing by the same volume. So we can say that gamma, which is the specific weight, is equal weight per unit of volume, and weight from the previous section, okay, we said that weight it's equal mass multiply acceleration for gravity, so we can say mg divided by v. And from the above, from the definition of density, we can see that m over v is equal the density. So we can write or rewrite or rearrange the equation as rho g. Okay, so the specific weight has different forms, different expressions. Okay, one is the main formula, which is weight of over volume, and the other it could be expressed and written by rho multiply g. Okay, so we have finished from the rho, which is density, and specific weight, which is gamma. Now, what about specific gravity? We have two types. These are the derivation of the specific weight. So specific gravity, we have two types of specific gravity. We have specific gravity for material, and material is classified in liquid and solids, okay? And the other type is specific gravity for gases, okay? For gases. So what about, or how to find the specific gravity of material? The specific gravity of material is defined as the ratio, okay, of the density of the material to the density of reference material, which is used as water. Okay, so if you have any material, material X, if someone asks you find the value of the specific gravity of material X, you will say that rho of that material X, you will divide it by the rho of water. So all the time the water is fixed. However, the material is changing according to your application or your question. Okay. Uh, Someone will say that there is another formula that we can use the gamma of material divided by gamma of water. Why? Because gamma, we said that it's a rho multiplied g. So rho of material, which is the density of material, multiplied g, divided by rho of water multiply g. And here the g are same, so we can cancel the g with each other, and you will have the same main formula. So whatever you have, either rho or gamma, you will get the same answer. Okay, you will get the same answer. Now this is for material. So in the material, it depends whether you have a solid or liquid material. Okay, you will divide by the density of the water. Now, what about the second type? The second type is the gas, the specific gravity of gases. So in the material, we take the ratio of density of the material to the density of water. However, in the gases, we will take the ratio of density of the gases, okay, whatever the gas you have, and you will divide it by the density of air. So in the gases, we have the reference as air, and in the material we have reference as water with similar formula. Okay, so these are examples and exercise. Let's have the first example here. We have an unknown liquid. Okay, so you don't know the liquid, And we know that the properties like density and specific weight, okay, each material has some different value. So there is no two materials having the same value. That's why they call it properties. Okay, so خصائص المادة أو خصائص المواد معناها إنه كل مادة تحمل قيمة مختلفة عن الأخرى في هذه الخصائص، مثل الكثافة والوزن النوعي اللي هو specific weight أو specific gravity. So unknown liquid substance has a mass of 18.5 gram. So write the given information. So here we have mass is equal 18.5 gram, which is equal, if you want to convert to kilogram, so 18.5 times 10 to the power minus 3 kilogram. Okay, so this is the first given information. Now, it says it occupies a volume of 23.4 milliliter. Okay, the question, I missed the question. The question, it says find the density. Okay, find the density of that liquid, of the liquid. Okay, find the density of the liquid. So here we have the mass and we have the volume as V is equal 23.4 milliliter, and this is equal 23.4 times 10 to the power minus 3 liter, and we know that 1 cubic meter is equal 1000 liter. Okay, therefore we can multiply this one by the conversion factor, okay, as a fraction, as we have studied in the unit conversion. So we will put liter in the denominator and cubic meter in the numerator, and we copy the numbers. So here 1000. Now we can cancel the liter with liter, and we have the answer as 23.4 times 10 to the power minus 6, because here it's a division by 1000 and here it's a division by 1000, which is 6 zeros, and the unit is meter cube. So the density simply has a formula of mass over volume. Now let's substitute for the values. Mass, we have 18.5 times 10 to the power minus 3 kilogram divided by 23.4 times 10 to the power minus 6 cubic meter, and the answer can be found as 23.4 minus 6, and the answer is 790.59 kilogram per cubic meter. Okay, this is for the first example. The second example, it says try to pause the video and solve the question. Okay, try to pause the video and solve the question using the above formulas. Okay, so here it says if the density of water is 1000 kilogram per cubic meter, so density of water is 1000 kilogram per cubic meter. Okay, it says, sorry, it says find the specific weight of water in SI and English units. Okay, so the specific weight of water is going to be the answer. Okay, so you need to solve for specific weight. Okay, what is the formula for specific weight? Specific weight of water, it is the rho of water multiply the acceleration of gravity. Okay, So what is the raw of water? You just substitute, direct substitution, 1000 kilogram per cubic meter times 9.8 meter per square second. So the answer is going to be 9800. Now look, these units, okay, will form what? Mass. So here we have mass, and here we have acceleration of gravity. So mass multiply acceleration of gravity, it's a weight. So the unit of weight or force, it's a Newton. So we will say that 9800 Newton divided by, here we have cubic meter. So the unit of specific weight is Newton divided by cubic meter. And we can say 9.8 kilonewton per cubic meter. It is the same answer. It's just divided by 1000 to convert it to kilo newton. Okay? Now, what does it say? In the question, the second part, it says convert it or find it in English unit as well. In English unit, the specific weight has a unit of pound as one example per cubic feet or pound, which is pound force, huh? Per cubic inch. So try to find and convert between these two. If you know that one pound force is equal 4.45 Newton, okay? And if you know that 1 feet is equal 12 inch is equal 0.305 meter. So how to find the square and cube of this relation? You can cube the whole relation, okay, and do the same and solve it as an equation, okay? So in the equation we said whatever you do on one side, you do it in the same side to keep the balance. So you can square both sides, you will get feet square as a relation with meter square or inch square, and you can cube both sides to get cubic feet with a cubic meter and cubic inch relation. Okay, so example 3, here it says calculate the mass. So it's asked to find the mass of a material, okay, of such a material, and that material has specific gravity. Specific gravity of that material is equal 1.26, okay, and the volume of that material is equal 0.45 cubic meter. So where we can find the mass? Where we can find the mass? Where mass we can find the mass in the density, okay? So we know that the density is equal mass over volume. Therefore, mass, we can rewrite the equation or rearrange it to have rho times volume, okay? So, do we have the rho? No, we don't have the rho. Do we have the volume? Yes, we have the volume. So we try to find the rho, the density of the material. So where we can find it? What is given in the question, he gave the specific gravity of that material. And we know that specific gravity of material, okay, is equal the rho of the material divided by the rho of water. Therefore, we need to find the rho of the material. So rearrange the equation as rho of material is equal specific gravity, okay, of the material multiply rho of the water, right? We just take this water and multiply it on the other side. So it was a division, so we transfer it as, we move it as a multiplication on the other side. So just substitute the value. Here we have 1.26 times, we know the density of water is 1000 kilogram per cubic meter. Why I use the kilogram per cubic meter? Why I don't use 62.4 pound per cubic feet, which is the same density of water in English system? Because in the question he mentioned the SI units, so it's easier for me to use the SI unit of the properties or the density. So here the answer is 1260. So 1.26 times 1000 is equal 1260 kilogram per cubic meter, and this is the density of the material. Okay, this is the density of material. Therefore, we can say now we can substitute M is equal rho of the material multiply the volume, sorry, multiply the volume, okay, and rho is equal 1260. Let me write here the unit in other color, kilogram per cubic meter, times the volume, which is given as 0.45 cubic meter, 0.45 cubic meter. And we can see that cubic meter can be cancelled with the other cubic meter for the density, and we left by kilogram, which is a unit of mass. So we just do the calculation and do the math, and 1260 multiply 0.45, the mass is 567 kilogram. This is the mass of the material. This is the mass of the material. Okay, so these are examples. Try to answer the following exercise. Exercise 1, if the density of mercury, and exercise 2, what will be the specific gravity of water and air. Okay, and exercise 3, what is the weight of water inside container with volume of 4.3. And these properties of matter, we are going to use it a lot, okay, in the next lecture, which we will talk inshallah about pressure, and uh, from next week, from next lecture, okay, we will start in the deep instrumentation and measurement one. So we will start studying the basic concept of the physical quantities like pressure, level, and so on. Okay, so in order to go for the pressure, okay, with a full confidence, you need to know all whatever we have learned and studied for these two lectures. You need to know exactly the basic math. You need to know the properties of the matters, mass, weight, density, specific weight, specific gravity. You need to know only the differences. I do, it's not that difficult, okay? But I don't want from any of you to mix between these terms, okay? Just know the differences, understand them, and everything is going to be easy, inshallah. So that's all about this lecture, and we will meet, inshallah, in the live sessions, inshallah, with your discussion and your questions uh, and your answers, of course. Okay, so see you, inshallah, next week, and have a good day and week, inshallah. Good luck. See you.